Okay, so I'm hoping I'll have a little better luck doing this video and not not like the last one. So we'll see what happens. Okay. Remember that when we're looking for focal length, that c squared is always equal to a squared minus b squared. Okay. Now, the last examples had equations. Here I have a picture, but I can still figure out what our values of A and C are, right? So like, looking at the lines of symmetry, like there and here, like I should know that, okay, my center is equal to -3, 1, right? So that's where I'm going to be deviating to get my focal distance or focal length. It'll be in the y direction because that's the major axes. And then again, just simply counting 1, 2, 3. So my b value is equal to 3. And 1, 2, 3, 4, 5. My a value is equal to 5. So again, c squared equals a squared minus b squared. So c squared equals 25 minus 9. C squared equals 16. So that's actually really nice, right? Plus or minus 4. Try to erase that 3 and make it into a 4. Okay, try to erase that 3 and make it into a 4. So plus or minus 4. So we're going to go 4 from this center. So again, it's in the y direction. So -3, and then be 1 plus or minus 4. So that would be like -3, 5, or -3, -3. Now those are actually really nice values that you can actually plot, and you know exactly where they are. Okay, let's look at the next example. So, again, looking at the line of symmetry here, that's helpful to find the center, right? So find your largest value. So the center is right there. So that's over 1, 2, 3, 4, 5, 6, 7, up 2. 1, 2, 3, 4, 5, 6, 7, up 2. If I counted that right. So then I know that my b value, 1, 2, 3, 4. So my b value is equal to 4. My a value would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then I know that c squared equals a squared minus b squared. So c squared would be 100 minus 16. So c squared is equal to 84. So c is equal to plus or minus the square root of 84. That's 4 times 21. So that's equal to plus or minus 2 root 21. And again, that we will deviate in the center, but it's an x direction. So, we're going in this direction and going in that direction, get those 2 focal points. And so then the deviation from 7, and you could leave it as 7 plus or minus 2 root 21, comma 2. Like you could leave it as like a collection of those 2 points, almost as if you had solved it using the quadratic formula. Okay, now there's a definition of a word that describes, I guess, the stretchiness, for lack of a better word, of an ellipse. It's called eccentricity. And the more stretchy or the more it deviates from a circle, the more eccentric it is. And so we're going to define a ratio to be c to a. So again, c is the focal length and a is the length of the major axes. So you think about if your c, remember this is always your a value here. A. So like the closer that C becomes to A, if C and A, become the same distance, then your eccentric value is equal to 1. But like if it becomes smaller, if C gets smaller, smaller, and smaller, then your C to A ratio gets really, really close to 0. And so then like a circle would have an eccentric value of 0. So I think again, like those 2 focal points, if they get closer and closer together till they become like just 1 point, then your ellipse has become a circle. So that's something else you might think about, like the eccentricity of a circle. Eccentricity of a circle is 0. In other words, it's not eccentric at all, right? Eccentricity of a circle is 0. Okay. So let's find the eccentricity. So we know that here, a squared is 36, b squared is equal to 14, which means, again, a squared a squared minus b squared would equal c squared. So 36 minus 14, which is 22, sorry. So c squared equals 22, which means c is equal to root 22. And since we need eccentricity to be a ratio of c to a, that would be root 22 compared to the square root of 36, which is 6. So there's our eccentric value. It's just a measurement. The closer you are to 0, the more it's going to be like a circle. The closer you are to 1, the stretchier it's going to be. And we're going to find out that it can't ever be equal to 1, then it becomes a whole new conic section. So let's find the eccentricity in each of the ellipses in example 2. So going up here to example 2, we knew that our c value was 4, and our a value was 5. So c to a, so for that one, our c to a ratio, so c to a would have been 4 to 5, or 0.8. Okay, and then in the next part of example 2, for right here. So then we said this c value was 2 root 21, and our a value was 10. So 2 root 21 over 10. C to A would be 2 root 21 over 10. Now, sometimes the question comes up like, could it be negative? And the answer is no. Your eccentric value will always be a positive ratio. So, even though like sometimes we think about there's a negative connotation with C and A because you're either moving to the left or to the right, as a general rule, your eccentricity will C to A will always be a positive value.